We're in the final section of our introduction to semiconductors, and we're going to take a brief look at troubleshooting them. Mechanical considerations: leads should be bent with needle nose pliers. Some semiconductors have glass packages and need to be handled with care. Repetitious bending of the lead can cause them to break. And over here there are some pictures of right and wrong ways to do things. Here we have a very sharp bend. When you have a very sharp bend, you run the risk of weakening the wire connection. You could actually break it if you bend it too many times. The gradual bend is much better. Here we have a bend that is really too close to the package. It may damage the package. It's much better to have something like this so that you don't risk damaging the package. Like I said, often these are ceramic and you could break them quite easily. Soldering and desoldering. Troubleshooting often requires the component to be soldered or desoldered into or from the circuit board. Semiconductor devices are temperature sensitive, and caution should be used in soldering and desoldering. Okay, they're temperature sensitive and the soldering iron is hot, and you don't want to destroy the conductor, when you're putting it into the circuit. Heat-sinking solid-state devices is essential to protect them from thermal damage. Okay, so a heat sink, your text has a picture of a technician using a pair of pliers as a heat sink when soldering the lead of a semiconductor. And so the pliers are between the semiconductor and the soldering iron, so hopefully they will absorb the heat. Okay, electrical conditions. Junction voltage measurements are useful in troubleshooting semiconductor devices. A forward bias junction will have approximately 0.7 volts across it. If germanium, it will be about 0.3. An ohmmeter can be used to test a PN junction. Now, one of the ways you can do this is to measure resistance across the PN junction. A front-to-back ratio of at least 1 to 10 should be the result of an ohmmeter test. So what this means, if you put the leads of the ohmmeter across the PN junction and you have it set to read ohms, the forward bias condition should be quite small, and the reverse bias condition should be at least 10 times that value. Some ohmmeters also have a special connection for testing PN junctions, and when you measure across them, it will read 0.7 volts in the forward bias condition and infinity in the in the reverse bias. Okay, that completes this the part about troubleshooting. We looked at electrical conditions, soldering and desoldering, and then we looked briefly at connecting them into the circuit.